If it's at rest and you exert a force at 12 newtons sideways on it, what happens? Not a lot. Actually, I mean, something does happen. Let's talk about that, right? But it's definitely not going to move because the force of friction, the static force, can go all the way up to 23.03. That's the max that it can go before it breaks free. 12 newtons is just going to amuse it just slightly, right? So here's this object sitting there on this surface, and you exert 12 newtons this way, right? Is that enough to break it free? No. It's 12 is less than 23.03, right? So what the object does is it exerts a force straight back on it, right? So if you got 12 newtons this way, it exerts 12 newtons the other way, okay? And if I exert 13 newtons this way, it exerts 13 newtons that way. If I exert 20 newtons this way, it exerts 20 that way. If I exert 23.02 newtons this way, it exerts 23.02 newtons that way, right? But if I exert, 23.04 newtons this way, it breaks those bonds, and then suddenly this 8.33 newton force, the kinetic force, becomes relevant. Okay, but the 12 newton thing does not make it break free. So the object stays still because this is what we need to write, right? Because the applied force of 12 newtons is smaller than the static friction, the max, static friction max, right? Of 23.03 newtons. Ta-da! You need to say what it is. You need to compare them, right? You have to say that it's the static friction, right? You could, I suppose, let's use fewer words. Let's see. The applied does not move. The applied force of 12 newtons is smaller than the static friction limit. I'm not doing much better. Of 23.03 newtons. That's fewer words. All right.